Alright, let's do a quick review of square roots. Okay, if I have these numbers and I take each one of them and I square, I get 1, 4, 9, 16, 25, 36, 49, and 64. And I could do this for larger numbers, but this is all the room I have, so I'll stop there. So if I wanted to approximate something, like if I wanted to say, well, what's the square root of 10? So the number inside, like for example, if I do the square root of 9, I'm looking at this number as my 9. My answer is 3. Okay, so the square root of 9 is 3. Now the square root of 10 is just a little bit bigger than 9. The 10 is a little bit bigger than 9. So my answer should be a little bit bigger than 3. Okay, and I'm just going to guess 3.1 for right now. So if I said, what's the square root of 15? Well, hopefully you would say, well, 15 is between 9 and 16, so I need my answer to be somewhere between 3 and 4. Now, because 15 is closer to 16, then my answer needs to be closer to 4 than it is to 3. So this is, I don't know, maybe 3.8 something. Okay, those are just guesses. So if I said, what's the square root of 40? Your approximation could be somewhere in here, maybe 6.4. Okay, and we could grab a calculator and we could check these. Well, what ancient mathematicians did, since they didn't have a calculator, is they came up with different ways to calculate a square root. And really, for the most part, they did it geometrically. Like, for example, if we wanted the square root of 10, then a perfect square that I know is 3, and then I have to figure out how to get, so 3 times 3 is 9, the area of this square is 9, so I'm missing 1, so I need to think, well, let's see, this length is 3, so 3 by 1 is 3, that's too big. If I took 3 times a third, that's 1, so that's too big. So what if I took 3 times a fourth? 3 times a fourth is 3/4, so that's still going to be a little bit bigger. So let's do 3 times a sixth. Okay, so that means what I'm going to do is I'm going to make each side of these 1/6 units tall. Okay, so this is 1/6, and we know because we are started with a square, this is 3 times 1/6. So the area of this rectangle is a half, and the area of this rectangle is a half. And so in here, I have a quarter. So I could say, because I don't have a quarter. I have 1/6 times 1/6. Here's 1/6, and here's 1/6. So 1/6 times 1/6 is 1/36. So now this should represent a square, and if I look at the length of a side, I have 3 here, and this is 1/6 units long, so that's 3.16. So when they first started thinking about a square, and taking the square root of a number, they literally thought, how can we build a square? Now Newton did it a little bit differently. He said this idea. I can say, well, I can have a new guess if I take my old guess divided by 2 plus the number that I'm working with divided by 2 times the old guess. Okay, and we could totally illustrate this. So if I take 10, let's say I have square root of 10. Okay, so this is, I'm trying to approximate what this is, square root of 10. So my best guess, based on what we had back here, is I'm going to say it's around 3. That's all I know. Okay, so I'm going to take 3 over 2 plus the number that I'm working with is 10, and 2 times 3 is 6. Okay, now for simplicity, so we don't get lost with the fractions, we are just going to convert all of this to decimal, and we're going to add it up and get an approximation. So this is 3.16 repeating. Now what's pretty cool is just by doing this, we got the same thing that Egyptians did by using a picture. Okay? Now if I'm not quite satisfied with this answer, I can go again and I can say, well, 3.16 divided by 2 plus 10 divided by 2 times 3.16, and that's 1/6 repeating, so I should keep that. So I'm going to use that in my calculator. I'm going to take the number divided by 2 plus 10 divided by 2 times 3.16 repeating. And I get 3.16228, and it keeps going. Okay? Now, if I were actually just to take square root of 10 in my calculator, square root of 10 is 3.16227. Look at how close we are. Okay? And really, if we've been practicing our mental math the whole time, most of these calculations should be pretty easy. So let's try another one. Let's say we want to just figure out the square root of 85. Okay? What's your best guess? Well, 85, let's see, my next number would be 9, which is 81, and 10, which is 100. So my best guess is it's going to be a little bit bigger than 9. But I'm just going to start with 9. So 9 over 2 plus 85 over 2 times 9. So if I calculate that in my calculator, I get 9.22. Now, just for fun, I want to see how accurate this is at the beginning. So if I take the square root of 85 on my calculator, I get 9.2195. Look at, just after one calculation, I have a really good approximation. If I wanted to go again, I would take 9.22 divided by 2 plus 85 times 2 times 9.22, and I would calculate that. And I get even more accurate. So when I calculate this, I get 9.2195. Oh my goodness, after 2 iterations, I'm almost exactly there. So that's what Newton's method for approximating the square root of n is about. Okay, I hope that helps. If you have more questions, let me know.